Here, want to isolate y on one side, dy on one side, dx on the other. So these are already separated. Don't have a dy dx here. So let's see if separation of variables would work here. Then here we have 1 over y already. This is one term, so the whole term would go on the right side. So this would be equal to negative y e to the cos x sine x dx. Now the y is in the wrong place. It needs to join dy and the friends on the left side. So divide both sides by y. Notice that now you have 1 over y squared. dy on the left side, you still have minus e to the cos x sine x dx. So this is now what we have here. Well, turns out this is actually easier than the previous one. Have you seen that? Because now you have to integrate both sides, but here both sides are straightforward to integrate. We don't need those weird tan substitution and the likes. Here, the old classic integration works. Apart from that, the standard U substitution also works. To integrate the left side, we're going to take the y squared up, so it becomes minus 2 then. Had it been 1 over y on its own, the integral would have been ln y automatically. So I'm focusing on the left. To integrate this, add 1 to the power, it becomes minus 1. Minus 1 divided, so that now you have divided by minus 1, and then this will now be minus 1 there. And then when this reduces, this will just be negative 1 over y when it goes back down. That will be the integral on the left hand side. Now how about on the right hand side? On the right hand side, we're going to use U substitution. And how do we see that? We see that when we differentiate this, it gives us this part. It gives us what is outside. That is how you spot a U substitution in an integral. So I'll focus just on the right hand side, and we'll say let U be equal to cos x, so that now du dx will be equal to, when you differentiate, negative sine x. So that now dx, make dx subject, it will be negative du over sine x. I wrote theta, that's x. So from here, now substitute. On the right side, what are we seeing when we start substituting? We see that when we substitute, we now have minus e, where there's cos, we are putting u. The sine would still be here. Where there's dx, we're going to put this term, negative du over sine x. The sine x and the sine x will cancel. The negative and the negative will cancel. It's an important step in U substitution. The odd variable must disappear. The negative will go with this negative. So that now we only have e to the power u du. And when we integrate this, the integral of e to the u with respect to u, it will still be e to the power u. But since we are done, we can sum it up. We can even bring the constant here as c. We put back what u is. U was defined to be cos x. So that now we have 1 over y is equals to e, where there is u, we'll put cos x plus c. So this one, there are no complications. We can make y the subject of the formula. And here, to make y the subject of the formula, y, the negative will go to the right, and all these will now go in the denominator. 1 over e to the cos x plus the constant. Basically, I don't have to worry about the constant there. I can still add it separately and say plus c in the numerator. But since I brought it up early, I can still do this. So all these are negative. So basically, this is going to be our solution.